Hello everyone, welcome to my channel on data analytics. I am your host Professor Rage Uday Kiran. In this video, we are going to learn the basic classification technique called naive Bayesian classifier. We will be learning about this classifier in depth with a solid example and a demo performed on a real world very large data set. For demo purposes, we are going to use Python and scikit library. The coding will be done in Google Colab. In the KDD process, naive Bayesian classifier falls in the classification category which is under data analytics. Classification is an important supervised learning technique where the user will be providing the data along with metadata such as labels. The learning algorithm has to understand the relationship between the data and the metadata and build its model. Using that data, we try to further classify the unknown dataset. The outline of this video is as follows. First, we will look at the basic terminology needed to learn naive Bayesian classifier. Next, we look at the algorithm itself. Later, we will go through the classifier algorithm with a solved example. And finally, we will end this video with a demo. Classification is basically a two-step process. The first step is called induction, where we take the dataset called training dataset, input it to a classification algorithm, and we build the model. The second step of classification is called deduction. In deduction, we'll try to guess the class labels of test instances. That is, we have some data set, but we do not have the class labels. Given this incomplete data set to the model built by a classification algorithm, the model has to predict the class labels. This is the overview of a classification technique. Any classification technique has to perform these two steps, that is induction and deduction. Before learning any classification algorithm, the users have to learn two important terms. The first term is called mutually exclusive events. That is, two events are mutually exclusive if occurrence of one prevents the occurrence of another. For example, if I toss a coin, if it lands on head, the tail will not occur. Similarly, if we get tails, the head will not occur. So, such kinds of events are called mutually exclusive events. So, this is the first term the students have to keep in mind. The next term to keep in mind is independent events. That is, two events are independent if occurrence of one does not alter the occurrence of other. For example, assume that in one hand you have a coin and in another hand you have a Ludo cube. Now, the tossing of the coin and throwing of a Ludo cube have no correlation between the one another. Such type of events are called independent events. Conditional probability is a statistical measure that captures the probability of a class label given an attribute. It is a very old statistical measure that is widely studied in various data science techniques. For instance, confidence in association rule mining is also a conditional probability. Let us see how we determine the conditional probability with an example. So here we have a data set, okay, with the attributes day, outlook, that is whether we are having sunny day, overcast day, etc. Then we have the temperature of each day, the humidity of the each day, whether there what type of wind is there, and given these attributes we have a label called play tennis, that is whether a person is going to play tennis or not. So given this data, now we want to check the conditional probability. Since day value is different in every row, we remove this column because it acts as an identifier. Now let's go to the outlook. Now we want to check the conditional probability of outlook with respect to playing tennis. To capture conditional probability, first we take the values, all values of the outlook attribute, that is sunny, overcast, rain. Next we take the variables or values of the label play tennis, that is yes or no. In this data set, 7 rows are yes, sorry, 9 rows are yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly, 5 rows are no. Okay, so given this information, now we will draw a contingency table where we check for yes labels how many are sunny. Similarly, for label equivalent to no, how many are sunny. So this way we try to draw a contingency table. Once we have this contingency table, then the conditional probability is very easy to calculate, that is probability of sunny. Okay, so probability of playing tennis given sunny is 2 by 9. Similarly, the conditional probability of not playing tennis given the condition sunny is 3 by 5. So this way we will be calculating the conditional probability of outlook values with respect to the labels. So we can simply say 2, or we can also say 2 by 9. So the way we are going to use does not matter. So anyone can say, when you are building contingency table, you can either say 2 or 2 by 9. Both are valid because you are already writing the count of each class label's value here. In this data set, we are having only 2 class labels. If we have multiple class labels, then we keep all the class labels here and we build this M cross N contingency matrix. Before we are going to learn about Nye Bayesian classifier, I request all the viewers to pause this video and calculate the conditional probabilities of different attributes and their values. Please check your conditional probability values against the key provided here. If you have done most of these contingency tables correct, well done. Otherwise, please go back and try to work out once again. Prior probability. This statistic measure captures the probability of occurrence of each class label in the given dataset. For example, in our dataset, out of 14 instances, 9 instances have the yes. So, the prior probability of playing tennis equivalent to yes is 9 by 14, that is 0.64. Similarly, the prior probability of a person playing tennis equivalent to no in our data set is 5 by 14, that is 0.6. This is the prior probability calculation. Once we have the conditional probability and the prior probabilities, we simply use these measures for the Bayesian classifier. Let's learn how the naive Bayesian classifier works. So the formula for naive Bayesian classifier is shown here. We will now look at the description of this mathematical equation. First, let us start from here. So the K here represents the class label. That is, for each class label K in K, what we are going to do is, we are going to take the prior probability of a class label, and then we are going to multiply the each attribute that exists in the data with its conditional probability. And once we do it, okay, here we are going to take the maximum value out of the derived values and assign the class label as the corresponding one. Let us look at an example of predicting the class label using naive Bayesian. So, this is our mathematical equation for class label. So, given a particular data set that we have seen in the previous slides, we are now going to predict the class label for a test instance whose outlook is sunny, temperature is cool, humidity is high, wind is strong. Now, to predict the class label, first what we do is, we first try to come up with the probabilities of class label equivalent to yes and probabilities of class label equivalent to no. How do we do this? First, we take the prior probability of yes times what is the conditional probability of yes given the outlook is sunny, then what is the conditional probability of yes given the temperature is cool, and so on. Similarly, we will have the prior probabilities and conditional probabilities for no. Calculation of the class label for the given test instance is as follows. Now, the prior probability of yes class label is 9 divided by 9 plus 5, that is 14. So, this is the prior probability of the class yes. Now, let us look at the conditional probabilities of this class label yes given the attribute values such as sunny, cool, high and strong wind. So, probability of sunny for the class label S is, so when we look at the outcast, Sunny has two instances with the class label S. So the value is 2 by 9. Similarly, for the temperature cool, 3 instances out of 9 instances are cool. So it is 3 by 9. Similarly, out of 9 yes instances, 3 instances contained the humidity value high. So it is 3 by 9. Similarly, out of 9 instances of yes class label, 3 instances had the wind value equivalent to strong. So that becomes 3 by 9. Once we calculate it, we get the value. Similarly, now we calculate the probability for the class label no. So, first we calculate the prior probability of the class label no, that is 5 by 14 into, out of 5 instances, 3 instances of Sunny were no. So, 3 by 5. Similarly, 1 by 5, 4 by 5 and 3 by 5. So, we calculate these probability values. Once we calculate the probabilities of class labels, we choose the maximum class label. Here we can see that for the class label no, the probability value is high. So, we say that the chances of playing tennis is equivalent to no. This way, we assign the class label for a test instance using Bayesian classifier. Now, we will perform a demo on air pollution data using Bayesian classifier. The demo is as follows. So, given the KDD framework, first we will take the raw air pollution data of PM 2.5 values for each sensor at hourly intervals. So, first we will download it. Once we complete this, we select the target data of a particular sensor. So, this sensor data is our target data. Next, we perform pre-processing on the target data by removing abnormal values and replacing the missing values using linear imputation technique. Once we derive the pre-processed data, we transform it into a transformed data set by extracting the information from the timestamp. For example, from this timestamp, we extract the day, which day the particular timestamp belongs to, what part of the day, whether it belongs to morning, night, afternoon, early morning, so on. Similarly, hour type, that is peak hour or non-peak hour of the transport. We will perform these steps. Later, we have these pollution values that we convert it into categories. Since Bayesian cannot handle continuous values, we convert the pollution values into categories using the standard measurements given by the domain experts. Once we have this data set, we input it into a Bayesian classifier. For demo purposes, we are going to use Google Colab. The code for the demo is available at my GitHub. Please come to the GitHub repository Intro to Big Data at Uday lab, and you can check the class number. Class 9 talks about classification and knife base. So please visit the folder of class 9 and check the notebook. So please click the link open in Colab to open the entire demo in Google Colab. So now I will explain the steps one by one. First, we are downloading the dataset from the GitHub repository. Once we are downloading the dataset, we are reading it into a data frame. Later, so this data frame represents the entire data. In the next step, we are creating a target dataset by selecting the timestamp and the PM2.5 values of a particular sensor. So these are the steps we are performing to create target dataset. So here you can see that I am selecting the data of a particular sensor, and then we are doing data pre-processing by removing the outliers and negative values. And once we complete it, we are going to extract the metadata from this timestamp, that is whether a particular day represents Friday, Saturday or Monday and so on. So we are getting the temporal information. Once we are doing it, we are creating the necessary steps. We are performing the necessary steps to create the data set for our analysis. As you can see here, from timestamp information, we are creating which part of the day. Next, we are looking at the time and creating whether it is a peak hour or non-peak hour. And then we are looking at the values, whether the sensor recorded level is healthy or unhealthy. Once we have created this data set, we are printing the final data set here. So in this 1, 2 and 3, the first 3 columns are the attributes. The last column is our class label. Now what we are going to do is we are going to split this entire data set into training data set and test data set. And in the test data set, we are going to predict the class labels and we check the accuracy. So to perform naive Bayesian classification, we are going to use scikit or sklearn. So in this step, we are taking the data and then we are applying the naive Bayesian classifier by performing k-fold test. So here we are splitting the data into 5 parts and then we are shuffling it, and for each shuffle we will perform naive Bayesian and we predict the accuracy. So the accuracy of this classifier is 100%, means naive Bayesian is working at 100% accuracy for this data set. In this data set, we do not have much variation in the data. So we have received 100% accuracy. If our data set contains multiple values, then the accuracy will fall down. So that's the overall demo of this video. Thank you very much for viewing our video. If you like our work, please press the like button, share it with your friends and subscribe to our channel for more interesting videos.